Hello, Lucy.
Hell yeah. What's poppin'?
Do you know what my name is?
Nice to meet you. What's your name, exactly?
My name is Elliot. What do you see in this picture?
In the current image, one can observe a monitor screen displaying someone's electronic workspace, which is likely a text or coding environment. An additional smaller screen can be seen placed next to the main monitor on top of a table or desk. A keyboard and mouse are also visible within this workspace area. The area around the monitors seems to be an office or workspace setting.
Awesome. How did you know it was a monitor?
Um, Good question. I was able to make an educated guess based on the context you provided, like the mention of Elliot and the time, which made me think of a computer screen. Plus, the image link, even though I didn't actually see the image, kind of hinted that it might be a digital environment. So, I took a chance and made an assumption.
Hey everyone, it's Elliot. Back to you guys with another episode on the channel here. And in this one, it's kind of a tutorial. So we're going to be going over how to set up this Llama voice assistant using Grok and 11 Labs. So let's go ahead and jump into it. First of all, you're going to navigate to this, which I will link in the description below. I'm just going to go and navigate to this Git repo. And pretty much what we're going to do is we're just going to clone this directly in. I'm not going to build up the code base or anything. I'm just going to kind of explain the logic of what's happening. And then we're going to just make sure that it sets up and get sure that it's working step by step. So I'm going to go ahead and just clone this part. You want to make sure that you have Git installed. So first of all, I'm going to SSH into my Pi here. Yes, enter the password, and we are in. Okay. So when you get the Pi the first time, you're going to do the sudo apt update and sudo apt upgrade. Upgrade just like this, and then you're going to sudo apt install git python 3 pip and vim if you want, and then zsh as well. So I'm going to go ahead and run this before we do anything, and it should get all of that working. So this part usually takes a while if you're just setting up the Raspberry Pi first, but that's not too much of a worry. I've already done this preemptively, so it's not going to take as long this time. It's just going to, it might install something new here. I think that might have been Python. But yeah, so that's going to finish up. Give that a second. But yeah, so we're pretty much going to use Grok in 11 Labs. So I'm going to go ahead and clone this repo in, and then we're going to set up all of that, and we're going to get it working. So the Raspberry Pi here is what this is running on. I'm gonna, first of all, I'm going to connect my camera here, and I need a camera for the vision feature, a camera for the mic, so the camera has a mic inside of it, and then I'm going to wire it into my speaker system. So I'm gonna go ahead and plug that in here, and then get my other cord. Where did it go? Right here. So I need the actual audio itself. I'm going to go ahead and put that behind. But really quick, we're just going to go ahead and install the rest of that. So I git clone this into here. That's going to take a second. I'm going to go cd into that. Now to install the Python packages, I'm going to take a slightly different route for installing the pip packages. We're just going to go to this Astral UV, this UV pip package manager. We're going to install this. So I'm just going to pop into here and just take the Linux command. We're going to install that. So this is going to take a second, but it's just going to give us really fast pip. It's just going to install Python packages really fast for us. So if I go ahead and exec zsh just like that, everything should go everything should be faster now. So I'm going to go ahead and make a virtual environment. Or we can just see if UV works in the first place, which it does. We're going to go and make a virtual environment. We're going to source it. So I can literally just take this command and paste that in. And then we're going to UV pip, or no, we don't do that first actually. We have to go into the README file and install a bunch of other things. So notice in here how there's some of these commands. So we have to install this stuff first. So I'm literally just going to quit this. I'm going to cat the README, and we're going to take this and we're going to paste it just in the terminal here. This should take a second. Oh, FS camera wasn't working apparently. Let me take a smaller compressed version of that. So that's going to install. This is going to take a little while. So in the meantime, we're going to head over to grok.com. So I open this. You say, for example, hello. It says, hello, nice to meet you. Very, very fast inference. We're going to use Grok for generating the text tokens that the voice assistant is going to be outputting. If I go ahead and navigate to products and then Grok Cloud, we can go ahead and see, we can go ahead and start building in the playground here. Now, I am already logged in, so I already have some keys here. But if we go ahead and create one, create API key, we're just going to name it, let's just say VA, voice assistant, submit. So give us this key. I'm going to paste this into, this is not finished downloading yet, but I'm just going to paste this into the ZSHRC file, and we'll see what that does. So in export, we're going to go Grok API key. Make sure it is spelled this way. It is very important that you get that correct. And then we're going to add another one below called 11 Labs API key. And we're going to set this 11 Labs. Go ahead and close Grok now. 11 Labs. We're going to go to app. I'm already logged in on this as well, but we're just going to go to API keys. You might have to connect something for this to work, but assuming that you've set up 11 Labs properly and you're in this section, you're going to navigate to the bottom, hit API keys, create a key. We're just going to give it a name, some random name, and then we're going to copy this, head back to the terminal, and we're going to paste that in. You can use Nano for this, by the way, as well. I'm just using Vim because I'm used to it and it's fast. We can go ahead and source that. And now if I echo, if I go echo Grok API key, to pass the $sign before it, and then echo the 11 Labs API key, that prints as well. I'm going to delete this, so don't worry about me exposing API keys. This is just temporary. But yeah, so I'm actually going to head back to this and enable some permissions for it. So we just made this one right here. So I'm actually going to edit this and give it the text-to-speech access. Save changes. Yeah, so now you can pop back here. This is done now, so I can go ahead and source CSHRC, and we'll just exec CSH, see if that, okay, awesome. Yeah. So now we can actually pip install everything. So if I go uv pip install -r and then requirements.txt, everything should go. Should be pretty fast here. Some of them might take a little bit longer. I know speech recognition is built in, so this is Google Speech Recognition. It's built in and it takes a little extra time to install, but that's perfectly fine. Now, just looking back a second here, we still do have to install these libraries here. So I have to go ahead and install those in a second. But yeah, so I have to, it says require dependency exception JPEG. So I have to go sudo apt install. Then I have to navigate back here and make sure that these are properly installed. So this just means, best camera. So this just means lib, so JPEG library on device. So it's a device specific thing, and it's the library for it using JPEG. And then FFmpeg is a little different. You might already know what FFmpeg is, but it's just going to help with a lot of the encoding and decoding and just universal audio and video stuff. So FFmpeg is extremely useful. It's used everywhere, but yeah, we'll give this a second. Now, before we continue, I actually want to show you something that is going to be helpful in case something doesn't work. So if you go sudo raspi config in a different terminal session connected to the Raspberry Pi, you'll actually get this menu here. And this gives a few things. So you have system options, and in here you want to make sure you look for audio, right? Audio is what we care about in this case. Vision, that's just gonna work with the stuff we're using, but what we care about is audio. So you want to make sure that this is the correct device that you want. So notice here how we have two devices, but what I care about is the headphones. That is what we want. That is the audio jack, right? So we're gonna make sure that we have this. Your device is gonna be different, of course, but this is just to make sure that you understand how to do this part. We can go to performance, no. We go to advanced options, audio config, and then we should just have pulse audio there, which should be the default. So it turns out that it's actually FS webcam and not FS camera. So you're gonna go sudo apt install FS webcam, just like this. I go ahead and install that. It's installed already, so it's just gonna say that's the newest version, but that is the correct term. So now if we go and actually run this, the v1 script. Hello, Lucy.
Hell yeah, what's poppin'?
What's in this picture?
A laptop with a black screen displaying many lines of code. These lines are visible because the laptop is turned on at an angle.
Awesome. How do you know it's turned on at an angle?
Because the screen's reflection, it's not symmetrical, you know? It's a bit distorted, which suggests the laptop's not directly facing the camera.
Awesome. Do you know what my name is?
I'm afraid I don't. Sorry. I'm Lucy, your friendly voice assistant, and I don't have any information about your name.
There you have it. That's Lucy. Have fun with her, you know? There's more you can add to it. I might add an upgraded version using some of the Anthropic models, like 3.5 Sonnet, but that's not currently a feature. So this is designed to primarily be super fast inference. I specifically use the, in here, I explicitly use the fast, where did it go? In here, I use the super fast Turbo V 2.5 model. So that's when it takes the model output and transcribes that into an MP3 stream. So we use the super fast model. It is optimized for latency. So that the higher you increase this number here, the more optimized it is for latency. So it'll be faster at responding. And then we use the we use the lava model here. So this is a vision. This is a vision language model. It kind of has both modalities going on, so it's able to essentially convert images to text, and it can help us understand with its eyes here, right? It's kind of a vision feature. So that's integrated into the whole pipeline, the whole conversation. It's the context is appended, and it handles that very nicely. So we're using a very cheap and inexpensive vision model for that, and then we're using the Llama 3. Where did it go? Up here. The Llama 3. Oh, did I lose it? 70B. Yeah. So Llama 3 70B, 8K context length. So that's good enough, right? You're gonna get your responses like super fast. You can tell how fast this is just on my laptop and Raspberry Pi alone. It's really fast, especially given the Raspberry Pi's hardware. I'm quite surprised by how quick it is. But yeah, so feel free to tweak with some of these parameters here. There's like a wake word time, the voice ID, which you can change from 11 Labs. It's just a charismatic female voice that I put in there by default. You have the style, stability, similarity. Feel free to tweak around with those and see what you can do. But yeah, the code is fairly well structured. It's got like it has a function for playing the audio. It has a function for getting the audio, like getting the input and just waiting for the person to say Lucy. It'll have an encode image feature, so that'll take the existing binary file that was captured by FS Webcam, and it'll put that into format readable by Grok, so Grok can process that. It captures an image. It can play a text-to-speech response, so it'll take the text, transcribe it really fast to MP3, and then it'll actually stream that as it's being outputted, so it's instant, right? You're not just making an MP3 file and then saying it after. You're creating it, and during the stream you're actually talking as it's going, right? So that's why it's really fast. And then just a main conversation loop here to maintain the context and handle the high level logic. But yeah, that's pretty much it. I hope you enjoyed this. It's supposed to be, super hackable. You can add more features to it. But yeah, this is Lucy.